Welcome to our channel Circuits Analytica. In this video, we will discuss some terminologies associated with network theory and network analysis. Interconnection of various elements like resistors, capacitors, dependent and independent sources are called as a network. Analysis of a network means to find voltage drop across an element or to find current flow through an element. In general, to find the response of a network to some type of input signal. Several theorems or laws are used for the analysis of linear network. Some of the commonly used theorems are Ohm's law, Kirchhoff's voltage law, Kirchhoff's current law, Thevenin's theorem, Norton's theorem, superposition theorem, etc. Now let us consider a simple network. This network consists of various nodes and meshes. So here, this is one node of a network. So this is second node, node number 2, 3, and this is the reference node of this network, common point to several nodes. And for this network, there are 4 meshes. So let us consider each mesh one by one. So this is mesh number 1, which consists of voltage source Vs, resistance R1 and R2. This is mesh number 2, which consists of 2 resistors and 1 inductor. This is mesh number 3, which consists of 2 resistors and 1 capacitor. And this is mesh number 4, which consists of 1 capacitor and 1 current source. For each of these mesh, we can define the mesh current, which is usually assumed in the clockwise direction. Now let us consider various branches in a network. An interconnection between 2 nodes is called as a branch. So this is one branch which consists of voltage source Vs. Another branch which consists of resistance R1, which connects node 1 and node 2. This branch connects node 2 and reference node. This one connects node 2 and node 3. This is a branch which connects node 3 and reference node. This branch interconnects node 3 and node 4. This is a branch which is connecting node 4 and reference node. This is another branch which connects node 4 and reference node. Various components in this network are resistors, then inductor, capacitor, then independent DC voltage source and independent DC current source. This is another network which consists of a DC cell and a dependent DC current source. The current source by this current source is denoted as 3V1, where V1 is the voltage at node 2. This is a dependent DC voltage source whose value is denoted as 5V2, where V2 is the voltage at node number 3. Now let us discuss some basic theorems used for the analysis of various networks. Ohm's law states that voltage drop across a resistance is directly proportional to current flow through the resistance. V is proportional to I. Or we can write V is equal to I into R, where V is the voltage drop across the resistance, I is the current flow through the resistor, and R is the resistance value of the resistor. So in this network, according to Ohm's law, voltage drop across the resistors are directly proportional to current flow through the resistor. VR1 is proportional to I. VR2 is also proportional to I. We can write VR1 is equal to I into R1 and VR2 is equal to I into R2. Kirchhoff's voltage law. Kirchhoff's voltage law states that in a closed loop, algebraic sum of all voltages is equal to 0. In other words, KVL can be explained as in a closed loop, sum of voltage drops in various elements is equal to sum of voltage sources in that closed path. Kirchhoff's voltage law is also called as law of conservation of electric energy. So this is a simple network which consists of voltage source Vs and n number of resistors R1, R2 to Rn. Is the current flow through this network. So according to KVL, we can write Vs minus of VR1 minus VR2 minus VR3 etc. minus Vrn is equal to 0. So here minus is common to VR1, VR2 to Vrn. So therefore we can rewrite this equation as Vs minus of inside bracket VR1 plus VR2 plus VR3 plus etc. plus Vrn is equal to 0. So Vs is equal to VR1 plus VR2 plus etc. plus Vrn. Kirchhoff's current law. Kirchhoff's current law states that algebraic sum of currents entering a node is equal to algebraic sum of currents leaving the node. In other words, according to KCL, for a node, algebraic sum of currents is equal to 0. Kirchhoff's current law is also called as law of conservation of electric charges. So here this is a network which consists of a current source Is and n number of resistors R1, R2, R3 to Rn. Current flow through these resistors are denoted as IR1 flowing through resistor R1, IR2 flowing through resistor R2, and IRN is the current which is flowing through resistance Rn. There are two nodes in this circuit marked as node P and node Q. For node P, Is is the incoming current and the other currents IR1, IR2 to IRN are outgoing currents. So according to KCL, total currents entering a node is equal to total currents leaving the node. So here Is is the lone current which enters the node and the currents which leaves the node are IR1, IR2 to IRN. So according to KCL we can write Is is equal to IR1 plus IR2 plus IR3 plus etc. plus IRN. Thanks for watching Circuits Analytica. Enjoy learning.